All right, so for example 3, it says find the sum of the first 9 terms of the geometric sequence 2, -6, 18, -54, etc. All right, so we're after the sum of the first 9 terms. So this is a finite, sum of a finite sequence. All right, so we know that S sub n equals our first term times 1 minus r raised to the n over 1 minus r. Well, let's go through. We're looking for the sum. Do I know what n is? Say it again.
Is it 9?
Yes. It's however many terms we're looking at. So 9. Do I know my first term? And do I know my common ratio? Well, a way to find the common ratio, if they don't tell me, is I can take my second term divided by my first term. So it's -6 divided by 2, which is -3. And you can look through here. Is 2 times -3 -6? And -6 times -3, is that 18? And 18 times -3, is that 54? Yes, so it worked. All right, so let's find it. So the sum of the first 9.
Wait, in order to always find the ratio, it's always the first and second, right?
Well, each second divided by the first. We could have taken the third divided by the second. If I'd have taken the third divided by the second, we'd have said 18 divided by -6, which is still -3. All right. Any term number divided by the one in front of it will give us our common ratio. All right, so back to our equation there. So the sum of the first 9 terms equals our first term, which is times 1 minus r, which we said was -3 raised to the n, which is 9, over 1 minus the -3. Now notice, when I put the -3 in there, I didn't change it to a plus, because remember PEMDAS tells us we have to do exponents before we multiply, right? So I have to deal with that -3 to the 9th before I'm allowed to deal with the minus in front of it there. So let's work through this. So the sum of the first 9 is equal to 2 times 1 minus, what is -3 to the 9th power? Remember, when you put that in your calculator, put -3 in parentheses. -19,000 what? 83. Anybody else get that? Over 1 minus the -3. Now we can deal with our minus and negatives. So we got 2 times, what's that, 19,684 divided by 4. And so let's see what our sum of our first 9 terms is going to be. I'm not for sure, I just did that in my head.
Yeah, well, it's 42.
It's 42? Yep. All right. And so there's the sum of the first 9 terms of that geometric sequence.